Hey everybody. So yes, I'm from frosty Finland. Name's Gabriel, and I'm going to be talking to you about the generic principles of writing native add-ons for node.js. So not like, you know, what to put in your package JSON, what to put in your binding JIP, but like what are you going to be faced with once you start writing this stuff. So the assumption I'm going to make throughout this whole talk is that you don't want to implement any logic in C++ as part of your Node.js bindings. You already have a library that does all the important stuff, but it doesn't work with JavaScript. You can't use it with JavaScript. So what you do is you write a very thin layer of bindings on top of a C library, and then if you want abstractions, if you want fancy schmancy, you do that in JavaScript. JavaScript is great for that. So the benefits of doing that is that you keep the binding simple, as one-to-one as possible, with the caveats listed at the bottom of the slide, and you can even like reuse the C API documentation. I've done this often in the bindings that I have used after I've written them. So two things that you really don't need to expose to JavaScript are function pointers, or rather the context of function pointers, because in JavaScript, it's very easy to make a closure and pass any and all data that you need. You don't need to pass that all the way through to C and then back to JavaScript, just so you have context. And the other thing you don't need to worry about is this C thing, where if you have an array, then you always have a pointer, and then you have an integer that is the length. I mean, JavaScript arrays obviously have them, so you don't need to worry about that. So the general principles that I found are very useful when writing bindings for a C library are to always trust data from the native side, because the native side is strongly typed. An integer is an integer, a string is a string. You don't need to worry about validating data types. And if the data is wrong, well, the data is wrong. I mean, you didn't write the library. You're just conveying the data to JavaScript, so you don't validate it yourself, right? On the other hand, when stuff is coming in from JavaScript, you have to treat it as like quote-unquote hostile, because I mean the JavaScript is loosely typed, right? So you know you have to check, what is this? Is this even an integer? And if I'm supposed to put it in an integer and it's not, you know, bail, throw an exception, return false, whatever. So don't proceed. And the other thing I found is that you know, avoid this thing that people do in JavaScript functions, where you know it can take one parameter and then it does one thing. It can take two parameters and then it has a default value for the third parameter and so forth. And then there's always like this little chunk of code at the top of the function that like massages the parameters. So don't do that in C++. I mean, what's the point, right? You're going to write the abstraction anyway that does all that fancy stuff. So require things to be simple and throw an exception if they're not, as expected. So another thing that I found useful is that the bindings should mimic the way JavaScript works, right? JavaScript has exceptions. If an exception happens, it tears down everything and it jumps to the nearest exception handler. So it's a good idea to write your C++ the same way. And the way to do that in C++, you can't just tear down the stack. You have to return, right? But if you use this signature where you have a Boolean and then you fill out everything in the parameters, you have like output parameters, then if anything goes wrong in the validation, then you just bail immediately, return false. And return false basically means an exception was thrown at some point, so just tear everything down, and when you get back to the actual binding, the outermost function written in C++, which has been called from JavaScript, you just return right away. You just skip. So if you do that, these functions can then be composed. So for example, when you're dealing with data, write a pair of transformations, one from JavaScript, one to C. You're probably going to need them. Of course, if the data only goes one way, there's no point in writing the other transformation, suffice it to say. So this is an example here of how to write like a converter. Since we have chosen, this is for sending stuff from JavaScript into C. This data structure that I showed you before, how do we convey it to C? My suggestion is, or what I've found that works, is to validate this block right here. I don't know if this goes to the screen. Well, there it is. So up here, you do the validation, right? You get this generic value, right? If it's not a number, throw an error bail, right? And then the other thing you should be doing is that I found is that if you're filling out the C structure, then don't don't actually fill it out, but make a local variable, fill that one out, and only if all the validation is good and everything, only then should you touch the one passed in, because you might end up returning that. So don't have like a half filled out structure, because you have all kinds of like inconsistent data that way. So, and actually one of the checks which I could have had here but didn't is this checking for whether these values are empty, because in recent versions of Node and in V8 they introduced this API called maybe values. So in the process of retrieving a property from an object, an exception may be thrown, in which case the property retrieved is an empty value. It doesn't actually have anything. So if you assume that it's a fully qualified value, then you're going to segfault. And so this toLocal checked, if I do this before checking it is empty, this could actually segfault. But well, you can add that if you want. I haven't added it for this example. So as you can see, these converters that I showed you, they follow the signature. So, and because they do that, you can composite them. So if one structure contains another structure, then if there's then you can call the function which converts the inner structure, and if there's an error, because it returned false, and so you can just return false. You don't need to throw the exception again, because you know that the exception was thrown at the point where the validation failed. So that's also another good idea. Don't, like if you get returned false, don't assume that you now have to throw an exception. But throw it immediately as soon as something fails. So going in the opposite direction is pretty simple, right? Because you've got stuff coming in from C. It's pretty reliable. All you need to do is just set the properties on the structure, and you're all good to go. So, but one of the artifacts of C that's going to kind of bleed through to JavaScript is that sometimes you have an empty object and you're going to be filling it out instead of creating a new object. So to cover both cases, you can use this C++ default parameter thing, where if the parameter is not specified, then you just create a new one. So you have this kind of thing which only works in C++, but that's okay because we're dealing with that. And these converters can also be composited, right? You can just call the helper function, which converts the smaller structure, and assign the result to the bigger structure. And so your code looks really neat that way. So now you want to start taking this big giant library that has these big giant APIs with all kinds of enums and defines and functions and stuff, and start exposing it to JavaScript. So you're going to be tacking a bunch of stuff onto module exports, right? So the way I do that systematically is, if at all possible, automate the parsing of the headers, because declaring a million variables and maintaining that and finding which enums have changed from version to version is a nightmare to do by hand. So try if at all possible, try to use either Node for parsing the headers, or the usual suspects like cat, grep, and awk. So that way you get a structure like the one at the bottom of the slide, where in your header you have number defined, some constant 5, right? And so you end up with like module.exports some constant equals 5, basically, except declared in C++. And for enums, it's kind of good to have the name spacing, because in C you don't, like you use the enum as if it were a constant, but in JavaScript it's a good idea, because you get this nice sort of a semantic relationship, like this constant refers to this particular enum, so it should be used in these contexts. So the simplest binding, it takes primitive values, it returns a primitive value, and here you do all the validation at the top, and all of those macros, I showed you how they're implemented. Basically, you throw an exception and you bail, and in the end you end up calling the C API area of oval, and then you set that as your return value, and that's it, right? Now, when you're dealing with data, that's when things get interesting, right? Because data is anything that doesn't fit into a primitive value, and in C that means a pointer to a structure usually. And so as soon as you're dealing with pointers, most APIs have two kinds of pointers. You have like just a structure where you don't care about the actual pointer, you just want to know what's in the structure, and then you have these things called handles, which are kind of like file descriptors or database handles, or something that represents a resource. And those are sometimes represented with pointers, but those pointers are irrelevant in terms of what's stored at the pointer. On the other hand, the value of the pointer is extremely important. So when you're dealing with structures, this is how you would do it. You would basically use the converters that I described earlier. So when you're getting a structure from the C, you convert it to JavaScript down there. And otherwise you return nothing, see, because it says if return value, so if the C call was successful. So this also means that you can't automate this stuff, like you can't automatically write functions because you have to know the semantics of the API, and at that point that kind of precludes scripting the translation process. So in the other direction, again, use the converter, and if it fails, you bail because you know an exception was thrown, and so you behave like JavaScript, you bail immediately out of the function. Otherwise, you call the C API. So when you're dealing with handles, you have a problem. You can't really send the handle to JavaScript because how do you render it? Like an array or what do? You don't want to send like raw pointer values as bytes to JavaScript. That's just a bad idea. I mean, what if somebody changes it and then sends it back to you? Now you're dealing with a rogue pointer, right? So fortunately, V8 and a lot of other JavaScript engines provide you with a way of attaching data to an object instance which is not visible from JavaScript at all. And the way you do that in V8 is you declare a new type of object, like a constructor, and then you can use this C++ only mechanism of reserving a location inside each object instance for setting like a void star. So here's an implementation that you can use to basically use this mechanism to attach your void star and create a corresponding JavaScript object, which although it looks empty, is actually very special because it has this internal pointer that cannot be seen. And so now you have a unique JavaScript object corresponding to a unique native handle, right? And so how do we do that, right? Like up here at the top, we basically declared a new type of object. This is the constructor. And then we need two things, right? We need to create a new one, obviously. Here's the native one, give me the JavaScript one, and then you pass that off to JavaScript, right? And then we need the opposite, right? An object comes in from JavaScript. Is this really a handle, or is this some arbitrary object that you just created with a pair of braces, or what is it? If it's not the handle, then throw an exception and bail because, you know, it's the wrong type. I mean, you can type things in JavaScript using, you know, constructors at least. So at least there's that. You have some assurance that, you know, you're not going to try to use a database handle as a file descriptor, you know, accidentally. So you check it. If it's no good, you bail, throw an exception and bail. And the other thing where you can be graceful is what if somebody has already closed this handle, right? JavaScript has different semantics from most C libraries. When you close a file, like let's say you get a file descriptor, you close the file. After that, the file descriptor is invalid, right? So if you try to close a file again, what happens then? How does the system fail? Like Unix will say -1 as the return value or something, but you're not necessarily dealing with Unix here. You might be dealing with any old C library. So you wanna kind of avoid this. You want to avoid sliding out of sync with the native handles. And the way you can do that is when somebody calls a function from JavaScript that you know is going to close the native handle. Again, notice that you need to follow the semantics of the API here. You need to know them. Then you invalidate the native handle by setting the value to null that's stored inside the JavaScript handle. And then it becomes like a hollow shell of an object. And then if you get past an object that passes the type check, so it looks like a database handle or whatever, but there's nothing inside, then you can throw an exception saying, listen, buddy, you already released this resource, you know? And that's a lot better than passing it through and potentially segfaulting. So this is how you use the class that I showed you earlier. It's really cool. You can give it a class name, and now all your objects are going to appear as remote resource handle in the debugger. And so it's going to be like remote resource handle brace unbrace. And it's really nice because you look at it and you know that this is a handle. You don't try to, like, you can set properties on it, but it's not going to do you any good. So this is how you use it. You get it back. You get a native handle from the C API, and then you wrap it in a JavaScript handle and you return it. So one important thing to remember here is never to make two JavaScript handles for one native handle, because then if somebody closes it, there's still a native handle floating around which looks perfectly valid from the JavaScript perspective, but which doesn't refer to any real resource anymore. So, for example, if you have a callback, then you would be tempted to return this, for example, here, because the callback gets this resource as a convenience from the C library, but you don't want to just create a new handle here, because this callback wouldn't have happened if you hadn't already created a handle. So it's better to pass in a persistent and then dereference that and pass it to JavaScript, because then you maintain this one-to-one-ness. So this is the real doozy here, the callbacks. I talked about void star context at the beginning, and this is super essential that the C library that you're looking at have these context parameters for all their callbacks. If it's a poorly written C library and it expects you to pass a function pointer, but it doesn't also expect you to pass a context, now you're in deep trouble, because you have to resort to esoterical things like trampoline or FFI to create real closures in C, meaning allocate a chunk of memory at runtime, mark it as executable in a highly OS-specific fashion, and then insert assembly code which is specific to the OS and to the platform to create a new function at runtime. That's insane. I mean, it's being done in many places, but please, if you have a void star, then if you don't have a void star, file a bug against the library. Don't start with FFI, because it's just asking for trouble. And all because in C, it's so difficult to create a function at runtime, whereas in JavaScript, you can just throw them around and then create 59 new ones, and it's all good. So there are two kinds of callbacks that I've been able to identify, at least. There's the kind where it's like, read from a file, and when you're done, call me, right? And then if you pass that callback in, it's going to get called once and then never, ever, ever, ever again, right? And then there's the other kind of callback where you expect it to be called every once in a while until you say, okay, stop, right? And you have to treat them differently, because if they're not mutually exclusive, if you can say, let's say you have a callback that can return false, right? And at the same time, you have a function that says, stop calling this callback and release the underlying resource. Then you can end up in a situation where you check what the JavaScript says, and the JavaScript returned false. So you're like, I need to release the native resource, and I need to free this wrapper that I created. But what if the JavaScript callback that you called when you got called also freed it explicitly, because there's an API for it? Close this file. Right? So now you can end up with a double free, which you must absolutely avoid. And checking whether the native pointer is null allows you to do that here. But of course, with an explicit handle, the wrapper that you use must contain everything needed to remove it, right? So it ends up being kind of self-referential, because you have the JavaScript object, right, which contains inside it, inaccessibly to JavaScript, a native handle, but it also contains a pointer to itself, so that when you pass it to the callback as the void star, you can actually get the JavaScript handle out of it and check that nobody nulled it out as part of the JavaScript execution stack. So this is what that looks like. So over here, this is the implicit callback. It's very simple. You call it. It doesn't matter what it returns. At the end, you delete, because you know this is never going to happen again, right? But in the explicit case, you end up with a situation where you have to create this self-referential structure, because you end up passing this structure to the callback right here. So no, actually not right here. This is where you, this is where you pass it to the C API so that it can pass it back to the callback, and this is where it ends up, right? Well, no, this is where you delete it explicitly. See, there's all these delete statements if the C API succeeded. But at this point, the persistent still exists, right? And you need to make sure. Right, yes. So again, nothing you could automate, because this is AI complete, essentially. You need to know what the library does in order to do it. But anyway, so in here, this is pretty much the same as before, except you need to remove it, right? In the explicit case, you don't, because the only way you can do it is using the API, so you don't need to worry about any deletes in the callback itself. But in the hybrid case, you end up with a situation like this. Over here, you have just made a call to JavaScript, which could have called your explicit free function. And so at this point, you could have an invalid pointer, right? So you cannot reuse the pointer that you created here. See, this callback data star could have been freed, but you've already dereferenced it here. So if you just use data and assume that it's still a valid pointer, you're going to segfault right here if somebody's already freed it. So then what you do is you have a persistent reference to the JavaScript object which used to contain the data, and you know that persistent reference has the latest and greatest. So just grab it again. And if this time around it's null, then you're good to go. You know it's free, and you don't need to delete anything. So you can avoid this double free in this situation. And besides, this is going to throw an exception, right? So you will actually get an exception at the JavaScript level saying, buddy, you freed this twice. You better check your code. So that's actually very good. But anyway, I think that concludes my talk, and I just want to give a shout out to the Node.js API guys, because they're working to make native add-ons better. You don't need to bother recompiling all the time. You write an add-on, you install a new version of Node. Once it will have this feature, and your add-on will just keep on working. So here's to you guys. And thank you, everybody. If you have any questions, and if I have time for questions, I don't know, then I'll welcome them, or we can talk offline. And that's it.